computer located behind a motor control center, with a wall in between, is experiencing power supply failures. Several potential causes could be responsible. Firstly, electrical transients and surges. Motor control centers can generate electrical transients and surges during operation, which can potentially reach the computer through the wall. Secondly, electromagnetic interference, or EMI. Motor control centers emit electromagnetic fields that can interfere with electronic devices. Thirdly, voltage fluctuations. The computer may be connected to an unstable power source, causing voltage fluctuations that damage its power supplies. Fourthly, faulty wiring or grounding. Poor wiring or grounding can create a path for electrical noise and transients to reach the computer. Fifthly, static discharge. Electrostatic discharge from personnel or equipment can damage sensitive electronic components in the computer. Sixthly, overheating. The environment behind the motor control center can be hot and humid, which can cause the computer's power supplies to overheat. And seventhly, power factor correction issues. The motor control center's power factor correction capacitors can create harmonics that can disrupt the computer's power supply. Several mitigation strategies can be implemented. 1. EMI shielding. Install EMI shielding between the motor control center and the computer, such as metal sheets for conductive fabric. Use shielded cables to connect the computer to external devices. 2. Surge and transient protection. Install surge protectors or transient voltage suppressors at the computer's power inlet. Use power conditioners to filter out electrical noise and surges. 3. Electrical isolation. If possible, install a transformer to electrically isolate the computer from the motor control center's power supply. Use galvanic isolation devices or optical fiber connections to prevent electrical transients from reaching the computer. 4. Wiring and grounding. Ensure proper wiring and grounding of the motor control center and the computer. Use shielded cables and grounded metal enclosures for all electrical connections. 5. Electrostatic discharge protection. Establish an electrostatic discharge control program in the area around the computer. Wear anti-static wrist straps and use electrostatic discharge safe mats and containers. 6. Cooling. Provide adequate ventilation or cooling mechanisms around the computer to prevent overheating. 7. Power factor correction. Evaluate the power factor correction capacitors in the motor control center. If they are causing harmonics, consider replacing them with passive filters or active power factor correction devices. In addition, monitor the computer's power supply voltage using a multimeter to identify any fluctuations. Perform a thorough inspection of the computer and its connections for any damage or loose connections. Contact the manufacturer of the computer or power supplies for technical support and troubleshooting assistance. Understanding each of these causes in more detail is key. Electrical transients and surges are brief, high-energy disturbances in the voltage or current of an electrical circuit. They can be caused by various factors, including lightning strikes, switching of electrical equipment, and inductive load switching. Motor control centers, which control and protect electric motors, often involve the switching of large inductive loads, which can generate significant transients. These transients can propagate through the electrical system and reach sensitive electronic equipment like computers, potentially damaging their power supplies. Electromagnetic interference, or EMI, refers to the disturbance caused by electromagnetic fields that can disrupt the operation of electronic devices. Motor control centers can emit electromagnetic fields due to the flow of current through conductors and the operation of electrical equipment. These fields can interfere with the functioning of nearby electronic devices, causing malfunctions or damage. The severity of EMI depends on the frequency and intensity of the electromagnetic fields, as well as the susceptibility of the electronic device. Voltage fluctuations refer to variations in the voltage level of an electrical power supply. These fluctuations can be caused by various factors, including changes in the load on the power system, variations in the supply voltage, and faults in the electrical wiring. Computers and other electronic devices are designed to operate within a specific voltage range, and voltage fluctuations outside this range can damage their power supplies or other components. Faulty wiring or grounding can create a path for electrical noise and transients to reach sensitive electronic equipment. Poor wiring practices, such as loose connections, damaged insulation, and improper grounding, can increase the susceptibility of electronic devices to electrical disturbances. Grounding is an important safety measure that provides a low resistance path for fault currents to flow back to the source, helping to prevent electrical shock and equipment damage. However, if the grounding system is not properly designed and installed, it can become a source of electrical noise and transients. Static discharge, also known as electrostatic discharge, refers to the sudden flow of electricity between two objects with different electrical potentials. Static electricity can build up on people, equipment, and surfaces due to friction, induction, or other processes. When a statically charged object comes into contact with a sensitive electronic component, such as a computer's power supply, the discharge of static electricity can damage or destroy the component. Overheating can occur when electronic components are operated in an environment that is too hot or when they are not adequately cooled. The power supplies of computers and other electronic devices generate heat during operation, and this heat must be dissipated to prevent the components from overheating. If the ambient temperature is too high or if the cooling system is inadequate, the power supply can overheat, leading to premature failure or damage. Power factor correction is the process of improving the power factor of an electrical system. The power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased energy consumption, reduced system capacity, and voltage drops. Power factor correction capacitors are often used in motor control centers to improve the power factor. However, these capacitors can also generate harmonics, which are unwanted electrical frequencies that can distort the voltage and current waveforms. Harmonics can interfere with the operation of electronic devices and can damage their power supplies. Now, let's explore the mitigation strategies in more depth. EMI shielding involves the use of conductive materials to block or reduce the transmission of electromagnetic fields. EMI shielding can be achieved by enclosing the electronic device in a metal enclosure, applying conductive coatings to surfaces, or using shielded cables. The effectiveness of EMI shielding depends on the frequency and intensity of the electromagnetic fields, as well as the material and construction of the shielding. Surge and transient protection involves the use of devices to protect electronic equipment from voltage surges and transients. Surge protectors and transient voltage suppressors are designed to clamp the voltage to a safe level, preventing it from reaching the sensitive components of the equipment. Power conditioners can also be used to filter out electrical noise and surges, providing a cleaner and more stable power supply. Electrical isolation involves the use of transformers or other devices to isolate the computer from the motor control center's power supply. A transformer electrically isolates the primary and secondary windings, preventing electrical noise and transients from propagating from one side to the other. Galvanic isolation devices and optical fiber connections can also be used to prevent electrical transients from reaching the computer. Proper wiring and grounding are essential for preventing electrical noise and transients from reaching sensitive electronic equipment. All electrical connections should be made with high-quality connectors and cables, and the wiring should be properly routed and supported. The grounding system should be designed and installed in accordance with applicable codes and standards, and all equipment should be properly grounded. Establishing an electrostatic discharge control program can help to prevent static discharge from damaging sensitive electronic components. The program should include measures such as wearing anti-static wrist straps, using electrostatic discharge safe mats and containers, and controlling the humidity in the area. Adequate ventilation and cooling are essential for preventing overheating of electronic components. The computer should be located in a well-ventilated area, and cooling fans or other cooling devices should be used to dissipate heat. The ambient temperature should be kept within the manufacturer's recommended range. Evaluating the power factor correction capacitors in the motor control center can help to identify and address any harmonics that they may be generating. If the capacitors are found to be causing harmonics, they can be replaced with passive filters or active power factor correction devices. Passive filters are designed to block specific harmonic frequencies, while active power factor correction devices use electronic circuits to cancel out the harmonics. Monitoring the computer's power supply voltage using a multimeter can help to identify any fluctuations in the voltage level. This can be done by connecting the multimeter to the power supply terminals and observing the voltage reading over time. If the voltage fluctuates significantly, it may indicate a problem with the power supply or the electrical system. A thorough inspection of the computer and its connections can help to identify any damage or loose connections. This should include checking the power supply cables, connectors, and circuit boards for any signs of damage or corrosion. Loose connections should be tightened or replaced. Contacting the manufacturer of the computer or power supplies can provide valuable technical support and troubleshooting assistance. The manufacturer's technical support team can help to diagnose the problem and recommend solutions. They may also be able to provide replacement parts or repair services. In summary, addressing computer power supply failures near motor control centers requires a systematic approach that considers potential causes, implements mitigation strategies, and involves thorough monitoring and inspection. By understanding the underlying principles and applying appropriate techniques, the problem can be effectively resolved.